All right, we're going to be working on building a session with the Go programming language and for web development. And I really like this. And at the same time, I've been struggling with making it as understandable as possible, while at the same time, having it be robust. So you could actually use it in a live situation, but it's also simple to understand because there's all kinds of different ways, different solutions you could come up with. So do you all want to just see what I've coded up so far, or do you want to code it up live and have me talk through it as I code it up live? What do you want? See it all done instead of like banging around the woods together? All right, so the place we're looking for the code is GitHub goes to 11, and go to Golang Web Dev if you're just finding this video online. And we are in sessions, 30 sessions right there, so we're working through that. And as always, Twitter, Todd McLeod, is where you can kind of stay update with all the stuff I'm doing, and I post my videos and things like that. So check that out. Follow me on Twitter. All right, so this is good because I've been refactoring this and I want to kind of get it clean. But the idea here is we have a UUID. We create a UUID. We store that in a cookie, and then, or we get back from the user every time the UUID, either because it's stored in a cookie or we've stored it in every link inside our website as a parameter, URL parameter. Does that make sense? Right? Parameters could be URLs, so links within our site that go somewhere else within our site. We just put a question mark and then dynamically stick this unique ID in the URL, and then anytime they click a link to go from one place to another place in our site, that unique ID is in the URL, and so it comes back to us, right? Because it hits the server, and we could check, is it there? Is it in the cookie or is it in the URL? So even if they don't have cookies, we can maintain state. So they have a URL, an ID, and then that allows us to know who's making the request. Let me get rid of that. And here's main.go. And so inside main.go, this will just be like a little code walkthrough. Create a user struct. And the user struct has a username, a password, a first name, and a last name. So that's how we store information about every user, which is why this is called user. And the password's a slice of bytes, and we'll see why that's a slice of bytes in a minute, because we haven't looked at bcrypt in here yet, have we, encrypting our passwords? So you should never store passwords on your server that aren't encrypted. And it should be one-way encryption, right? So you encrypt it, and that's it, it's encrypted. So it's some hashing algorithm that will encrypt, and then you can never unencrypt it. So it's just complicated. But then when somebody gives us a password, we could encrypt that, we could run that through the same algorithm, and it'll produce the same result. So we could take the encrypted result and compare it to what's stored in the database, and if they match, then the passwords match. Does that make sense?
Yeah.
Yeah, so that's how we do the passwords. So then we have TPL, template, and then template, must, template, parse, glob, templates. And so we're storing all of our templates in TPL. That makes sense, right? And then we have DB sessions and DB user. And those are two different storage areas. So in sessions, and this is just storing things in memory. It's like a hash table. It's just a lookup. It's a map, right? And so in sessions, we have a key, which is a string in the map, and then a value, which is a string. Okay? And so here we will store in DB sessions, the string will be the session ID. That'll be the key. And the value will be the user ID. So if somebody sends us a session ID, we could stick it into this, and it'll give us the user ID. And if we have the user ID, we could stick it into this, and that'll give us the user. Kind of cool, right? So I created a diagram to illustrate that. Let me see if I can find it. I don't think it's there. Here we go. So this is the idea. Client sends us a unique ID either in the cookie or the URL, right? Gets to the server, and then we take that unique ID and we can look up the user ID, and then with the user ID we can look up the user. Comprende? All right, so that's that. Now, why would you want to have that level of separation? Why would you want to do it like that? Why are we doing it like this? Security?
Is it for situations where people might have an account and you want to be able to store their history and information about their account?
Maybe. Let's look at Jeremy's suggestion first. Security. What security reason, Jeremy? It just seems like a good answer.
Well, it's just going through multiple levels. So
It's always a good guess.
it's kind of
Yeah, so security, we don't want to just use our user ID on the web page, right? Because then, you know, if somebody has the user ID, maybe they could get into somebody else's account more easily. Though if the user IDs were completely random and unique, then that odd would be 1 billion every second. For 100 years, you have a 50% chance you'd get one that's a duplicate, right? So really what this is one user could have many sessions. I could be logged in on my laptop and then go over to my desktop and log in, right? And I need to have many sessions mapped to one user. And the sessions are always going to be changing over time. So simultaneously, one user could have many sessions. And over time, one user could have many sessions. Because, oh, this session expired. We need to throw it away. And you know, we create a new session. Okay, associate with the user. It's connected to that user. So that's the main reason. And then I'm just going to, I use a composite literal here. So I'm making the map. Okay, so map is a data structure that needs some setup in the internals of Go. And so you need to make that map. And I think we looked at this before. Yeah, last week, did we not? We looked at, what was it that we looked at? We looked at the comma OK idiom last week, right? So we didn't quite look at this. Did we look at making a map? M : equals map string int nut, and I can do print line M and format and run. What happens is, oh, there's a map. And now that that's made, I could do things like M Todd is equal to 45, right? And run, and that's cool. So that's one way I can make my map, is just a composite literal, and it doesn't have anything in it. Another way I can make my map would be M : equals make map string int. And that also works, unless I made a typo. Okay? But this is just like I'm forcing it under the covers to make it. And the way that that's happening is it's a composite literal. Composite literal are the types, the curly braces, and the values. I'm just not giving it any values. Comprende? Cool. And then I'm just going to start this off by populating our database with one user. So if we wanted to, we could just try logging in as that person. So I'm going to create a composite literal, which is the type, and then the values. And the values are James Bond, slice of bytes not stirred, that's the password. This actually isn't going to work anymore now that I'm doing bcrypt, I don't think. And then James and Bond. So we might be pulling that out in a second. Like I said, this is code in progress, so I'll populate our DB. So I'd actually, to get this to work, need to store this after running it through bcrypt and not just slice a byte it. So that's what I'm doing, is like cleaning this up. I'm going to put in a little to-do password needs to be bcrypted. Okay. And bcrypt is the name of the algorithm we'll use for encrypting our passwords. So then we get to index. And I have a function getUser. And so I've put that function right here in session. And here's getUser. So request the cookie, give me the cookie. And if there's an error, that means there's no cookie, right? So the error's not nil, there is an error, there's no cookie. So in that case, create a new session ID. That's the UUID. We're using this package right here. So you have to go get that. And HTTP cookie, and if you don't understand, if you're watching this online, you don't understand what go get means, then go check out Udemy's course that I have on the Go programming language. And then here's a cookie. So, right, a cookie is just a type that's a struct, and we're getting the address of it, so pointer to cookie. And we're populating only the fields name and value, and the name of the cookie session, and the value is that UUID. It's all straightforward. And then we're going to set some fields on the cookie. And the reason I'm setting these fields out here is because when the cookie comes back from the browser, when a browser sends a cookie back, all it's sending back is the name and the value. It's not sending back to me, hey, this also had HTTP only, and the max age was this, right? It's also only secure. So I want to set these fields out here, and that one's commented out because we're working with this on HTTP. But I want to set these fields out here. That way, if I ask for the cookie, all I got back were the name and the value. I'm going to add these things back to it, and then add these fields back to it, and then reset the cookie. And that means on every request, I wanted a session to time out after 20 seconds. So on every request, right, it resets the cookie so that you can only be logged in for 20 seconds without activity. If you're inactive for more than 20 seconds on my website, it logs you out. And I did 20 seconds because I don't want you to wait 10 minutes to see if it actually worked, right? But in production, in the real world, you'd crank this up. Everybody following? Nina? All right, Patrick, you good? Cool. So then we set the cookie. And there's some to-do in here too. So I'm just going to drop a little to-do. And the to-do is for session to only last 20 seconds without activity, right? To expire, let's do it. For session to expire after 20 seconds of inactivity, reset cookie on every request. Right? We need to reset the cookie on every request. And my code's not doing that so far, so maybe we'll fix that up. So then, hey, I have the cookie, so I say, okay, my sessions, and I pass in the session ID, the cookie's value, and I get the username and whether or not it's okay. And we're using the comma OK idiom. And if you don't understand that, we learned about that last week. You could go through my YouTube videos at YouTube, Todd McLeod, and find the one where I talk about the comma OK idiom. I tweeted it too, so you could search my tweets for the comma OK idiom. Todd McLeod. I think there's a way to search just my tweets. Search Twitter, tweets. Seems like there should be a way that you could search. But you could just, I don't know, here I'll find it for you. Find comma. So here's comma OK idiom. And there should be one more mention of it. There we go. And it's right there. So you can check that out. Go web session and comma OK idiom. So search my YouTube videos for that. All right. So let's look at that. So if it's okay, meaning I actually had a username there, then I could go for DB users, pass in the username, and that gives me the user, and I can return that user. Hi, Alex. That makes sense? Cool? All right, so that is this first one here. Get user, I get my user, and then I execute my template, and I pass in my user. So my user might have fields populated or not. Like this is just user, a struct with no fields populated. And that's the user if this got populated. And in my template, I have an account for that by my template just saying, hey, if this field is there, then I'm going to assume the rest are, and we could print out the values. Okay? Yeah? All right, so that's that part. Are there any issues with that? Like, see, I have get user here, I have get user here. At login, I don't have get user, so I'm not asking for my cookie because you're logging in. So that kind of makes sense, right? So my session's not going to restart. Like, you know, the inactivity, I only get 20 seconds, and then I have to reset that cookie, otherwise it's going to expire. So if I go to login, I don't need to reset a cookie. If I go to logout, I'm requesting the cookie, but I don't reset it because I'm logging out. So yeah, I reset it, but just with like this cookie's done and it expires. So that makes sense. And then sign up, I don't need a session there. So I guess that's okay. And on every other page, I'm going to be getting the user, which is going to pull the cookie again and reset those fields. Right? So I have index, I have sign up, login, bar, I have index and bar. Let me just change the order of these. Sign up, log in, log out. So index, I guess like that order. I don't know. But index and bar are going to be, you know, resetting the cookie in terms of the session resetting. Does that make sense? You guys follow me? So that's index. And then we have bar. And we get the user again. And then we execute template on bar. And I wanted to make bar restricted. So that's something that I'm still working on. So I have restricted right here. And I wasn't quite sure the right way to do this, so we'll look at that in a second. Let's just look through the rest of the code first before we look at, you know, making it restricted. To do, make bar restricted to someone logged in. And I'm going to take out this to do because we just checked all of our code and it's working for all of our code. So just as those thoughts arrive, I'm dropping the to do. Right? So we could always go back and be like, oh yeah, that's right. That's one little thing we got to follow up on, make sure it's all working. And there's a way here in WebStorm you can look at your to-dos. Do you see that? I could come in here and here are my to-dos. Takes me right to them. Isn't that sweet? Nice, huh? Huh?
Yeah, I don't know if they have the same feature.
So now the login. If you come to the login page and you're already logged in, I'm not going to let you be here. So part of writing the code is writing code that's readable. And there's different ways I've tried to implement this. And I always came back to if already logged in. Because that just makes sense, doesn't it? If you're already logged in. That's just readable. So if you're already logged in, I'm going to redirect you. And for already logged in to work, it needs a request. So in the request, it's very similar to some of this other stuff. And there's trade-offs. Do I keep asking for the cookie? Well, the cookie is just an address. That's pretty light. It's a pointer, right? So that's not too bad to ask for. So, you know, if already logged in, you pass in the request, you get the cookie, here's the cookie. And here, instead of checking if error is equal to nil, meaning if error is equal to nil, there is a cookie. I just said if C is not equal to nil, meaning, again, there is a cookie. And I don't need the error. Does that make sense? I'm getting the cookie, and if the cookie is not there, the cookie equals nil. And if it's not equal to nil, the cookie's there. No?
Yeah.
Because I'm sometimes on the fence, like maybe I should just stick with, you know, the logic we know, which would be error underscore, right? And if error, well, no, let's do it like this, error. If error is not equal to nil, well, that means there's an error getting the cookie, and I want it to be there is a cookie. So if error equals nil, okay, we have cookie, right? Well, that's a little bit different, and somebody might read that, and that's not really the logic. Read that as like this because their eye just glances over it. They're so used to that. I'm really saying, hey, if there is no error, instead of there is an error, it's not nil. There is no error. The double negatives in that kind of get a little confusing, right? So that means we have a cookie. Or another way I could say it is if the cookie is not nil, right? We have a cookie. And I did a little experiment up here just to play with the cookies. Where I said, give me a cookie, which doesn't exist, and is cookie equal to nil and equals nil. So I was checking to see if we could, you know, if there's no cookie, if that equals nil, right? And then print it out. And when I run this, I gotta launch my web browser, sorry. I'm like, maybe it's firing up. Cookie equals nil, right? And you can see my fav icon got requested. Cookie equals nil. So that's cool. I could check against nil. If the cookie's not there, cookie is equal to nil, C is equal to nil. So I was just testing if that condition actually works. And if the cookie was there, but now I need a bar. So now I should be able to set the cookie. And I should be able to read the cookie back out. Cookie set. Right, now we have a cookie there. Now I go to bar. Gave me the type. If I wanted to, I could print the value. Set it, and then we go to bar. Oh, it gave me the new line, and then the comma space. That's funny. I added that in. And so that was just, that comma space came from right there. Right, I should have just done that. And it give me this, the type of the cookie, which is C, and show me the type. And then new line, and C value, which is a string, should give me that value. Right, and it gave me McLeod example. That's the value of the cookie. It's kind of fun, right? But you know, now it's bypassing equals nil because it doesn't equal nil. So that was just an experiment to learn about cookie. How many people that was like cool? You liked it, you got it. All right, so here I was kind of torn. Do I use error and say error is equal to nil because we have a cookie? Or do I throw the error away and just say, you know what, if the cookie's not nil, and that read best to me, right? Like if there is a cookie, then I'm going to get the value and do UN, get the username, and then when I have the username, I could get that and I could check for the user, but I don't need the user right here. I'm just checking if there is a user, so if that's okay, if that's true, then return true, you know, and otherwise return false. You know what would be an even easier way to do this, I just saw? Because this is a bool, and if it's true, I return true, otherwise I return false. So I could rewrite that, and I could say this. Right? Does that make sense? But is it less readable? Because now are you kind of like,
I don't understand why you changed it. It made sense to me before, but now I'm not sure.
yeah, this made sense to you, right? This stuff right here,
Yeah.
that made sense. And those lines right there are doing exactly the same thing as these lines right here. Because right here, underscore, throw away the user, okay, DB users in, right, is checking to see with the username, do we actually have an entry there? And it gives me okay. And then I check okay here with the comma okay idiom. And if that's true, then I return true. And if not, I return false. Well, this is going to be true or false. This is okay. That's a bool. So I could just return that true or false. So these two lines up here are the same as these 1, 2, 3, 4, 5 lines right there. But in Go, you write for clarity over brevity. You make your code readable as opposed to making it clever. So I would sit there and I think, are people going to understand that who pick up this code base? And Nina is like, no. Jeremy?
Yeah, that makes sense.
Patrick? Alex? A little bit confusing, right? So you have to come up a little bit, another step to sort of get the shorter way.
I get it now that you've explained it.
Good, then I'm going to leave it. What just happened with restricted? Was that not... I commented all that out and restricted blew up because I took away one too many curly braces. There we go. You want to be an even crazier way to do it? And this is the stuff where it becomes like you've gone for brevity and over clarity. Well, it's not that. Right? Like that is like, what the heck? But that's the same thing, right? I'm just taking the results of DB sessions and assigning it to UN, then sticking UN there. I could just do the substitution, put this stuff in right there. So, think about that when you're writing your code. Readability. And go for readability over cleverness. So, here it's clear I'm accessing DB sessions and assigning it to username. Here it's clear I'm putting in username and getting, the user out. Okay might be the wrong thing here with the comma okay idiom, but that's convention. Bool might be better because then it's clear that I'm returning a bool. But then that looks like a type. So I might just say B, but I think I'll stick with okay. All right, so I already logged in. So I redirect because I get true or false here. And if true, if they're already logged in, then go somewhere else. And then login, my template has a login form. And so if we're using method post, that form has been submitted. Do you guys need to see it or you got it? You want to see it?
Yeah.
So login, I'm way up here in the wrong one. Login, right, has right here a form. And that form has a username, a password, and submit. And we're asking for the email and the password as the placeholders. So, cool. So they submit that method post. So when method post comes in, we get the username, we get the password, we assign to UN and P, and we do DB user's username and get the U, right? And this is logging in. So do we need to check right there if there's actually a username? Like just checking our code there, that seems like a good thing to check. Is there somewhere else we're checking that actually returned a username? Or do we need another line of code there? If the username that came back is an empty user, right? Because the database will return an empty user. What happens when I compare the passwords? Am I comparing to nothing? Will that throw an error? Do you see what I'm saying? So let's go type that out at the Golang playground. Or you want to do it at the playground or just up in the student file so you have access to it?
Put it in the files wheel.
All right, so let's bang that out. And so as you're learning, doing these experiments helps you get to know the language. And we're asking here, user password thing. And so we'll create a new file, main. And this one is just main. And main. And we need a struct. And so type user struct. And we want, like password. And that'll be a slice byte. And just first will be a string. That was weird. And then inside func main, I'm going to do, I need some maps. So I need, what am I going to create now from the map? Is it a variable or a type? It's going to be a variable. So var db session is equal to, and then map string, and then composite literal. And we have db user is going to be that and a user. But we don't need this one because we're just testing this out. So we just need db user. So we have db user, and we want to check, like here in our code, right? We ask for a certain user, and it's not there. So let's do that. Let's take this exact line, copy that line, put it here. So hey, give me from db user un, and we'll just do un colon equal, hello, or bond, right? Bond doesn't exist in this one. And we pass bond in to db user, and that should give us back a user. And then we could do func.println user, see what that is. And we could also do func.println, and we could do u.password is equal to slice a byte whatever, something else, right? Awesome thing else. So we'll see, does that evaluate to true or false? And it might also just be interesting to print u.password. What is that? And we can do that with something on each side. So we could see if, what's on the middle. Let's run it. Invalid operations. uPassword. Invalid operation. uPassword is equal to slice a byte, something else. Slice can only be compared to nil. Slice can only be compared to nil. Slice a byte, uPassword, slice of bytes. So what did I do there? That's conversion. Let's just do this also, see what that is. And I need to string that to print it there. Let's comment this out for a second. So there is my user, nothing in it. Slice a byte and first name, right? Doot. And then here, and then it put nothing there. And then here's that other thing to compare it to. And when I compare it, I can't compare uPassword is equal to slice a byte. Slice can only be compared to nil. I don't know what that means. Slice can only be compared to nil. Because I could compare if these were slice of bytes, right? Like if I actually have a user there. So let me do like db user, and the username is, let me just move this down. The username is bond, and that's going to be equal to password, which will be slice a byte, shaken, not stirred, and first James. And I messed something up. Colon equals. No, that should just be equals, right? db user username is equal to user, the type, composite literal. So I'm storing a user in my database with the key of un. Is it good? You guys are bored. You need to code. Like, enough of you talking, Todd.
I think we're just tired.
un. So now maybe this will work because it pulls out a user, and then it'll print that out, and then it'll print out the password right there, and then, you know, here's, and if I do my passwords right here, we'll run it first where it doesn't work. '06 password. Invalid operation, slice a byte, something else. uPassword, I think I could compare strings. Slice can only be compared to nil. That's what that's telling me. What happens if I do this? Too much conversion. Let me clean this up. So there's that. And then I'm going to do right? String slice of bytes. That's just making it a string again. We're no longer comparing a slice of bytes to slice of bytes. So I guess we can't compare slices for equality. They could only be compared to nil. I'm learning something. So here is our stored password. Here is our inner password. And here is stored password compared to inner password. Uh, 19 and 21. 19. Let's try it. So that works. You can compare strings. So those compared to false. And if I change them to the same thing, true. So that's a good exercise. Slice can only be compared to nil. So equality on slice, right? Like, oh, wow, okay, so there's a little nuance of the language. And we could go look at the Golang spec. Golang spec. And we can ask ourselves, equality. And equality operators apply to operands that are comparable. The order operators, the terms and results comparison are following. Slice map and function values are not comparable. They have, like, these have underlying setup. And how would you compare one function to another? Right? So you can't compare slice things. Slice map or function value may be compared to the pre-declared identifier nil. Interesting. I wonder about structs. Seems like it'd be hard to compare structs. Struct values are comparable if all their fields are comparable. That's interesting. Two struct values are equal if their corresponding non-blank fields are equal. Whoa, isn't that interesting? Structs are comparable. You can compare one user to another user. It's the same user. How many people find that interesting? Yeah. How many people learn something about slices and maps?
Yeah.
Yeah, you could only compare them to nil. So now we understand.
Other people have asked the same question because it comes up on Stack Overflow a couple of times where people say you can.
So the point of that entire little exercise that we just did there was to see, okay, here we get U, and U is a slice of bytes. And we get the U password, which might be nothing if there's no user. And now we're going to compare nothing to a slice of bytes with compare hash and password. And that's another function from the bcrypt package. So I think at this point right here, we need to do this. And we need the user still. So we'll do that and do colon equal. And then say if not okay, and drop this in. Right, there's no username. Is there a username? And then here, does the password match? So for logging in, we get the username and the password, and we check, is there a username, right? And then we check, is the entered password match the stored password for that username? And if so, if we get past those two, if either of those hurdles fail, we just redirect, or we send back an error, status forbidden. And for the other case, we create a session. So we get the UUID, create a cookie, drop in the UUID. Here I put max age 20 right there because you're only going to log in if you're not logged in. Because if you're already logged in, you redirect. Does that make sense why I put it there as opposed to the other one I had it outside? Because the other one was outside because every time you might already have a cookie, right? And it gives you back the name and the value when you get the request, in which case you bypass all that. So let's add these back onto the cookie that came in. Because the only thing that comes in on a cookie is the name and the value. You aren't getting those other fields. So we set the cookie and they're logged in. And in DB sessions, we add the session ID. And we say that that's the value in that database is the username. So we created a new session for that user. That's login. So we've done index, we've done bar, we've done login. And next we have logout. So logout requests the cookie, C. And if there is no cookie, right, they don't need to log out. They have no cookie and need to log in. So let's just send them over to log in. And then we delete the session. So from DB sessions, delete that value. And you know what we need to do? Clean up DB sessions. Because somebody might not log out. And then DB sessions is going to get all these entries. So we might say clean up DB sessions every 24 hours or every 12 hours or every 30 minutes. And so we could just set a timer somewhere. And when that timer is done, we go through and we make sure that all the sessions have been used within the last 10 minutes. So we'll have to add a few fields somehow. And then remove the cookie. So name, value is nothing, right? And then max age is -1, means expire it now. Set it and redirect to log in. Or we could just redirect to home. You know, you're no longer logged in. What do you think, log in or home? No preference. Nobody has a preference. We'll send people to log in. And then sign up. If you're already logged in, you don't need to sign up. So just go back to the home page. But if you do sign up, you filled out a form with username, password, first name, last name. See, in here I'm checking, is the username taken? Right? So that's what I did up here under sign in. Is there a username? DB users UN. And here I'm checking, is the username taken? So DB users UN, okay. If it's okay, that username's already taken. Store user and DB users. So now if that username isn't taken and they're signing up, cool, you could have that username, we're going to store it. So bcrypt generate from password. And we pass in that password they gave us as a slice of bytes. And we pass in a cost. So we're just passing in from the bcrypt package the cost. The cost is how complicated it does it make it to encrypt it. The higher the cost, it kind of like will hash it and then take that result and run it through the hash and then take that result and run it through the hash. And so it just makes it jumbled, 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 jumbled. And if you only do it 4 times, okay, the cost is only 4. If you do it 4,000, then the cost of 4,000, it's more processing, but it's more jumbled. Right? So you put the cost in there because the higher the cost, the longer it takes your server, but the longer it would take somebody to try to hack it. So you just give it the cost and you give it the password. And the password needs to be a slice of bytes. So we use conversion to make it a slice of bytes. And then that gives us back a byte slice. And so we just check the error, and if there's an error, we log it and then return to the user, hey, error. And then we create a user, username, byte slice is the password, first name, last name, that's what came over in the form, that's our user. And in database, we store with a key of username, the user, and then we create a session, which is new thing, session, session ID, set the cookie, and in the database sessions, the session ID is associated with the value of the username. And then we redirect to the home page and we return, right? Because we're done sort of processing this form. And otherwise we're going to show the form sign up. That's it. You don't need a web framework. You don't need Revel, you don't need Gorilla. Right? Like we're really close to like hand coding our own web framework here. Log in, log out, sign up. There's a few things we need to take care of. Not many. Right? One of them is right here. Make bar restricted to someone who's logged in. How would we do that? So right now, get user is, it looks for the cookie. If there's no cookie, it creates a cookie, right? And then sets the timeout and everything on it. And then it tries to get a user. It might give us an empty user if there's no user. So we just need to maybe check, hey, if user.first, right? Oh, but it might have I'm just checking this out. See, this is where the logic gets a little complicated. But if they weren't logged in and they went to bar, we're like, hey, you got a cookie, gave us a session, you know, and then we looked up your username, and then you could be at bar, but you never logged in. But where did we get username? That's if the session already existed. So there wouldn't be a username. So maybe we could check the user first, because there wouldn't be a session, so there wouldn't be a username. Or there would be a session, but where have we associated the session with the... Yeah, no, this is the only place we're accessing DB session, so there wouldn't be a session yet. So I was thinking, and this is a bit of a mind trip. You guys had enough. You ready to code? That was a lot. Let's get you coding. All right, so this is what we're going to code. I want you to take session, start with session, okay? Actually, start here in 03. Hands-on login, and here's your starting code. And you're going to start with this starting code. And the thing you're going to do, use the code in starting code folder, create a login page, successful login for, and process a successful login for these credentials. A password field has been added to the user struct. DB user is populated in Funkinet. You do not need to protect any pages. Every page is accessible to everyone, regardless of whether or not they're logged in. Do not worry about abstracting code. You may notice redundant code. This is fine. So you need to create a login page in 03. So start with 03 and make a login page.